بسم الله الرحمن الرحيم.
Assalamu alaikum. Dear students, we are having exercise 3.3 from Mathematics, grade 6. That book is being published by KVK textbook book Peshawar. It's question number 1. In question number 1, we have been asked to write down the prime factors of 6, 140, 450 and 22,050. So these four values have been given to us and we are asked to write down the prime factor. Prime numbers are those numbers which can be divided by itself and by 1. So we have to find out, we have to work out those factors which can be divided by itself and by 1 only. I'm coming for the first one. There's 6. Now the prime factor of 6 will be like this. I wrote here 6, I draw 2 lines and I will take the lowest number by which 6 can be divided, that's 2. So 2 3s are 6 and 3 1s are 3. Therefore the prime factor of 6 is 2 into 3. You may write 1 or you may not write 1 because it doesn't matter, it doesn't do anything. Now coming to the second one, there's 140 and we have to find out the prime factor of 140. I'll write 140 here. I'll draw 2 lines like this. And you know, the last there is 0. Whenever there is 0, that number is divisible by 2. That number is again divisible by 5. And that number is divisible by 10. So we are taking the lowest one. That's 2. So I am going to divide it with 2. 2 7s are 14 and here again 0. Now again 0 means it is divisible by 2, it's divisible by 5 and it is divisible by 10. So I am taking 2 because 2 is the lowest value. Now 2 3s are 6 and here it's 1, 2 5s are 10. Here it is 5. Whenever there is 5 at the unit place, that value is divisible by 5. Now 5 how much are? 5 7s are 35 and 7 1s are 7. Now all of these numbers can be divided by itself and by 1. Therefore all of these numbers is 2, 3, 5 and 7. They are prime numbers. Hence the prime factors of 140 will be 2 into 2 into 5 into 7. You may write 1 or you may not write 1. Coming to the next one, it's 450. Now I'll write 450 in the same fashion, in the same way. There's 450 and in the last there is 0. It means that this value can be divided by 2, by 5 and by 10. And if I take the sum total of the digits, there's 5 and 4 come 9. When the sum total of the digits comes in the table of 3, so this value is again divisible by 3 as well. But I will take 2 because 2 is the lowest one. Now 2 2s are 4, it's 5. 2 2s are 4, here it will be 1. 2 5s are 10. Now 5, 6, 7, 8, 9. Means that this value is divisible by 5 as well and by 3. Why it is divisible by 3? Because if I take the sum total of the digits in the value, it's 2 plus 2 plus 5 plus 2 plus 2 means it becomes 9. And 9 comes in the table of 3. Therefore, this value is divisible by 3. Now, 3 7s are 21. Here is 15. 3 5s are 15. 75. If you take the sum total of these two digits, this value is because here is 5 at the unit place. So it's clear that this value is divisible by 5. But let me see, either this value is divisible by 3 as well. If I take the sum total, here is 7 and 5. If you add these two values, it becomes 12. And 12 comes in the table of 3. Therefore, this value is also divisible by 3. So I divide it with 3. 3 2s are 6, 3 5s are 15. And now 5, 5 5s are 25 and 5 1s are 5. Hence, the prime factor of 450 will be 2 multiplied by 3 multiplied by 3 multiplied by 5 multiplied by 5 and you may write in the last multiplied by 1. So all of these numbers are prime numbers. I can take here 25, but 25 will not be a prime number, it will be a composite number, and we are asked to write down the prime factor. Now the last one, that's 22,050. I'm starting this sum with the same way. I'm writing here 22,050. I'm drawing two lines here, and the last there is 0, means that this value is divisible by 2, this value is divisible by 5, and this value is divisible by 10. And now if you take the sum total, there is 5 plus 2 7 plus 2 9, so this value is also divisible by 3. But I am taking the lowest one, there is 2, so 2 1s are 2, 2 1s are 2, 0 comes down its own place, and 2 2s are 4, 2 5s are 10. Again there is 5, therefore this value is divisible by 5. If I take the sum total of the digits, 5, 6, 7, and 9. 9 comes in the table of 3, therefore this value is divisible by 3. I am dividing with 3 because 3 is less than 5. Now 3 3s are 9. Now I am going to divide it with 3. Now 3 3s are 9. If you subtract 9 from 11, there comes 2. So if we add a 0 into it, becomes 20. And now the table of 3 take 20 means 21. It's not 21, but it's 20. Now 3 6 are 18. Here again 2. Then became 22. The table of 3 up to 22, so it will be 21. And 3 7 are 21. Then it came 1, 15. The table of 3 up to 15. The 5 is 15. Now let's see either this value is divisible by 3 or not. We are taking the sum total of the value. There is 5, there is 7. Let's become 12. And 12 plus 6 become 18. And 18 plus 3 become 21. 21 comes in the table of 3. Therefore this value is again divisible by 3. So 3 1s are 3, 3 2s are 6, 3 2s are 6 because it's 7. And here 1 comes, it's a reminder, so it became 15, 3 5s are 15. Now the unit place there is 5, this value is divisible by 5, so I divide this value with 5. 5 2s are 10, then 22, and 5 4s are 20, there's 2 and 5, 25, 5 5s are 25. Again here at the last there is 5, therefore this value is divisible by 5. Now 5 how much is 20? 5 4s are 20 and 5 9s are 45. 49 is divisible by 7. 7 7s are 49 and 7 1s are 7. Hence in this case the prime factor of 22,050 will be 2 multiplied by 3, 2 times 3 and 2 times 5, 5 and 2 times 7. And if I want, I may write 1 or not. So these are the prime factors of 22,050. Prime factors are those which which can't be divided by any other number, but it can be divided by itself and by 1. Thank you very much. Bismillahirrahmanirrahim, dear students. We are having exercise 3.3 of mathematics book for grade 6, and that book is being published by KPK and Peshawar textbook board Peshawar. It's question number 2. In question number 2, we have been asked to find out the prime factor, but we have to write down this prime factor in index form. We have been given 4 values. One is 44, the other is 3,600, and the other is 1,250. The fourth one is 7,056. Now here, first of all, we will find out the prime factor. Prime factors in prime numbers are those which can be divided by itself and by 1. So, taking the first one, that is 144. It will be like this. 144, I wrote it here. I draw 2 lines. Now, in the last, in the unit place, there is 4, means that this value is divisible by 2. And this value is again divisible by 3. Why? Because if you take the sum total of these two digits, it becomes 9, and 9 comes in the table of 3. But 2 is the lowest, therefore I am dividing this value with 2, 2 7 is 14, and 2 2 is 4. Again, there is 2 is an even number, and when there is even number at the unit place, that value is divisible by 2. And it's also divisible by 3 because if you add 7 with 2, it becomes 9. And 9 comes in the table of 3. But I am dividing this value with 2. Now 2 3s are 6, and here becomes 12. Now 2 6 are 12. Now again here is 6. 6 is an even number, so this value is divisible by 2. And this value is again divisible by 3 because if you add 6 with 3 becomes 9, and then comes in the table of 3. But I am dividing this value with 2. 2 1 is 2, 2 8 is 16, 18. 18 is divisible with 2 because it is an even number, and if you add 8 with 1 becomes 9, and then comes in the table of 3. Therefore this value is again divisible by 3, but I am dividing it with the lowest value, that is 2. Now 2 9s are 18, and 9 is divisible by 3. 3 3s are 9, and 3 1s are 3. Hence, in this case, the prime factor of 144 are 2. How many times? 2 into 2 into 2, that's 1 2 3 4 times. 1 2 3 4 times. And then 3 into 3. These are the prime factors of 144, but we have asked to write down these prime factor in the index form. So in the index form, you will write here 2, and how many 2's are there? 1, 2, 3, 4. So its exponent will be 4. Multiply by 3, and how many? 1, 2. So the exponent of 3 is 2. It means that 144 are having 4 times 2 prime factor and 2 times 3 prime factor. This is the answer of the part 1. Now coming toward the second part. Here in the second part we have been given 3600 means 3600. Solving this sum in the same way. I wrote this value, I draw 2 lines. And now here are 2 zeros, therefore this value is divisible by 2 and by 3 because if you add these two values it becomes 9 and it comes in the table of 3, and this value is again divisible by 10, by 100 and by 4, but we will take the lowest one, that's 2. Here it is 2, 2 1s are 2, 2 8s are 16, and these 2 zeros again by 2, 2 9s are 18, and these 2 0 again by 2, 2 4s are 8, 2 5s are 10, and this one again by 2, 2 2s are 4, 2 2s are 4, 2 5s are 10, and if you add these 3 digits, it becomes 9. 2, 5 plus 2, 7 and 9. Therefore, it's divisible by 3, and it's also divisible by 5. But we are taking the lowest value. That's 3. 3 7s are 21, and 3 5s are 15. And again, this value can be divided. It's divisible by 3 because if you take the sum total of 7 and 5 becomes 12, and 12 comes in the table of 3. Therefore, 3 2s are 6, and 3 5s are 15, 25, and divisible with 5, 5 5s are 25, and 5 1s are 5. Hence, in this case, the prime factor of 3600 are 2 multiplied by 2 multiplied by 2 multiplied by 2. How many times? 1 2 3 4 times. Then 3 multiplied by 3 and multiplied by 5 multiplied by 5. So in index form it will be 2 and its exponent will be 1 2 3 4. In fact, its exponent is 1. Its exponent is 1 1 1. We are just adding the exponent of all the similar number. And here it will be 3 and it's 2 times, therefore I am writing here 2, 5, and how many times? 2 times. So this is in index form. Coming toward the other one, let me rub it out. The third one is 1, 2, 5, 0. And I wrote here 1250 or 1250. I draw 2 lines. In the last 0, therefore it is divisible by 2. So 2, 2 6 are 12, 2 2s are 4, 2 5s are 10. And if you take the sum total of these two values, it becomes, therefore it is divisible by 5 now. 5 plus 2, it becomes 7, and 7 6 is 13. 13 is not divisible by 3. Therefore, by 5, 5 1s are 5, 5 2s are 10, 5 5s are 25. Again with 5, 5 2s are 10, 5 5s are 25, and 5 5s are 25, 5 1s are 5. Hence, the prime factor of this value is 2 into 5 into 5 into 5 into 5. How many times? 1, 2, 3, 4 times. Therefore, its index is 2 into 5 and 1, 2, 3, 4. Its exponent is 4. So, this is in the index form. Now, the last one, that is 7056. 7056. And the last there is 6, and 6 is an even number, therefore it is divisible by 2. Now, 2 3s are 6, 2 5s are 10, 2 2s are 4, 2 8s are 16. Here is 8, again it is divisible by 2. 2 1s are 2, 2 7s are 14, 2 6s are 12, 2 4s are 8. 4 is an even number, again it is divisible by 2. So it is 2 8s are 16, 2 8s are 16, 2 2s are 4. Because 2 8s are 16, here came 1. 1 is added with the 6, it becomes 16. So 2 8s are 16, 2 8s are 16, and 2 2s are 4. Again with the 2, because here is 2 even number, 2 4s are 8, 2 4s are 8, 2 1s are 2. And now, if you look here, here is 4, here is 4. Become 8 and plus 1, 9. 9 comes in the table of 3. Therefore, this value is divisible by 3. Here 3 1s are 3. There became 14. 3 4s are 12. Here 21. 3 7s are 21. And again 7 and plus 4. It's become 11 plus 1, 12. 12 comes in the table of 3. Therefore, this value is again divisible by 3. 3 4s are 12 and 3 9s are 27. Because 12 means that when you subtract 12 from 14, here comes 2. And when you add this 2 with 7, become 27. 3 9s are 27. Now with 7, 7 7s are 49. 7 1s are 7. Hence, in this case, the prime factor of 7056 are 2 into 2 into 2 into 2. How many times? 1 2 3 4 times. 1 2 3 4 times. And 3 into 3 into 7 into 7. Now I am writing these prime factor in the what? In the index form. Now I will write here 2 and I will add here exponent 1, 2, 3 and 4. So its exponent is 4 and I will write here 3, 1 and 2. It's 3 is 2 times and 7 is 2 times. So this is the answer of part 4 of question number 2, exercise 3.3. Thank you very much.